This video is on volume to volume stoichiometry conversions. So in the previous video, you learned how to convert moles and volume using like decimeters cubed. So we talked about how molar volume is 1 mole equals 22.7 decimeters cubed. So we're going to use that again in this one. So in this problem, or these types of problems, you're going to start with volume, like decimeters cubed, and you're going to end with decimeters cubed. So it's just like the other ones we've done with mass and mass volume. We're just changing one of the units again on either end. So first we need a balanced reaction. So we have propane right here. It says it burns in oxygen, and oxygen is O2, to form carbon dioxide. So that's CO2 and water. All right, so we have a combustion reaction here. So before I even go further, I'm just going to write my reaction and balance it. C3H8 burns in oxygen, so plus O2. It's going to make CO2 and water. All right, so to balance this, it's always good to do these alphabetically. So carbon first, I have 3 carbons on the reactant side, so I'll need a 3 on the product side. 8 hydrogens in the reactant, so in front of the water, I'm going to need a 4. So 4 times 2 is 8. Then I add up my oxygens. So 6 in the CO2, 3 times 2, plus 4 in the water gives me 10, so that means I need a 5 here. All right, so now I'm going to talk about my path here. It says how many decimeters cubed of CO2. So under CO2, that's what I'm trying to find. And let's see, it's formed when 5.73 decimeters cubed of propane. Remember, propane is this guy right here. So that's my fuel, 5.7 decimeters cubed. So and just like all our other problems, first thing you have to do is convert to moles, because the only time you can change from one substance to another is in the mole unit, because that's what our coefficients are. They are our mole ratios. So moles of the CO2, and then back to decimeters cubed of the CO2. Now, what's interesting about these problems, when it's volume only, is that you are going to be using that molar volume right here in this step in the decimeters cubed to moles, and then you're going to use it again when you do moles to decimeters cubed. So you're going to end up multiplying by 22.7 and then dividing by 22.7. Actually, first you're going to divide, then you're going to multiply. So what happens here is that your molar volumes will actually cancel out. So I'm going to make this note. You might want to write this down, and then I'll show you what I mean. In volume problems, molar volumes cancel out. Therefore, you can skip these steps. Okay, I'm going to put in parentheses here though, but you don't have to. Oops. So this is a shortcut. You do not have to take it, but you definitely can. So I'll show you what I mean. So if I do this the long way, I start out just like we've done all our other problems. 5.7 decimeters cubed of the C3H8. So my first step is convert that to moles. So decimeters cubed of it on the bottom, moles on top. 1 mole decimeters cubed is that 22.7. So at this point, these divide out. So then I keep going. Okay, I want to cancel moles of C3H8 so that I can convert it to moles of CO2. And here's where I put in my coefficients. So 1 for the C3H8, 3 for the CO2. My moles of propane divide out. And then my last step will be to get rid of the moles of CO2 and convert that to decimeters cubed. And for every 1 mole, there's 22.7 decimeters cubed. And here my moles of CO2 cancel out. And I've now hit my question mark, so I'm ready for my calculator. But here's what I wanted to know. Here's what I mean with this. Right here and here, we have our molar volumes. And when you divide by something and then multiply by something, or multiply and then divide, it doesn't matter the order, they will be 1. You're taking anything divided by itself will equal 1. So you can actually skip these whole steps and just do this times your mole ratio. So here's what it could look like, and this would be totally acceptable. 5.7 decimeters cubed of C3H8, and I want C3H8 to cancel. And I want to change this to CO2. So I'm going to use my substances so I know what to cancel. My substance I want to cancel. But now instead of putting decimeters cubed, because I actually want that at the end, I'm only doing that mole ratio. So right, that's how this comes here. And then it's just the 3 to 1. And when I cancel, moles divide out and C3H8 divides out. So I'm left with decimeters cubed and CO2. All right, so 5.7 times 3 will give me 17.1 decimeters cubed of CO2. Now the reason we can only do this instead of with like when we have grams is because we're multiplying and dividing by that same number, that molar volume. The difference is in molar mass, it's a different amount. It's a different mass for every element or compound. So this is how you do a volume problem.